Unit 7, Day 1. Reviewing our properties of exponents. Product of powers. Here we have a multiplication problem. X squared times x cubed. Our final answer here is going to be x to the fifth. When multiplying, make sure you add the exponents. Here, 5x to the fourth times 2x cubed. Now, this one's different because, well, we have coefficients in front of our variables. Well, 5 and 2, those are not exponents. Those are regular numbers. So we're going to multiply them. 5 times 2 is 10. X to these exponents, add them. 4 plus 3 is 7. I'm going to start doing this one first. 4 to the negative second power. Well, 4 to the second power is 16. 4 to the negative second power is 1 over 16. So I guess one way you could think about it is take what would be your answer and flip it. X to the negative first power is just 1 over x. Here, we have 5x to the negative second power. The only thing that's being raised to the negative second power is the x. There is nothing wrong with the 5. So we would have to create a denominator and move that x to the bottom. It is now a positive exponent. This one here, x to the fifth, that's not a negative exponent. Y to the negative third, that one is. So x to the fifth is fine. Let's create a denominator. Move y to the third down in the denominator, and that third power is no longer negative. Here, x to the negative second power, currently negative in the denominator. So if we move it to the numerator, it is no longer negative, and we no longer have the need for a denominator. Quotient of powers. If you're dividing exponents, here we have a fraction, which is a division problem. You subtract your exponents. So x to the sixth minus 2, x to the fourth. That's your answer here. Here, this is the power to power rule. B to the third power times, I'm sorry, b to the third power raised to the second power. You multiply them. So b to the sixth. Here, notice that this time we have a coefficient which has a first power. You don't see it, but it is 2 to the first power. So this would be 2 to the first power times 3. C to the third power times 3. If we reduce, that's where we're at. 2 cubed is 8. 2 times 2 times 2 is 8. And stick with c to the ninth. All right, over here. Nothing I can do with that 2 for right now. Now I'm just going to start, rather than expanding this, I'm just going to start doing some quicker simplifying. 3 to the second power is 9. And d to the fifth power times 2 is d to the 10th. Now we can multiply that 2 and that 9. And there's your final answer. This one here, you have to square the numerator and the denominator. So we would do 4 squared over 3. Oops, I was thinking of the answer. 4 squared over 3 squared. And 4 squared is 16. 3 squared is 9. Final answer. Here, let's start cubing everything in this parenthesis. 3 cubed is 27. 3 times 3 times 3 is 27. C to the first power times 3 is c cubed. 2 to the third power is 8. And d to the second power times 3 is d to the sixth power. Now, what I'm going to do with this one, notice it's being raised by a negative exponent. Well, first of all, there's nothing in the parentheses that will simplify. So I'm going to leave the parentheses alone for now. Now I'm going to take care of that negative property I'm going to flip everything that's inside the parentheses. And now that I've flipped it, we no longer have a negative exponent. Now we're going to start squaring everything. 3 squared, 9. Y to the first power times 2. 2 squared is 4. And x to the first power times 2 is x squared. The zero exponent property. Anything to the 0 power is 1. So 5 to the 0 power is 1. Here we have 3 times x plus 3 raised to the 0 power. Well, x plus 3 raised to the 0 power is 1. And 3 times 1 is 3. Let's move over to side 2. Okay, you have been given a brief explanation on your power of your exponent properties. If you want to try this page to see if you're getting it, knock yourself out and then go and take a look at my Canvas page. And there you can find the answers. You can see how you're doing. And if you're just not getting them, talk to me during class. We can go over it together. Let's move over to side 3. All right, over here on side 3. Let me tell you what you don't want to do with example A. You don't want to start foiling this. If you start foiling this, it's going to take you quite a while, and you're going to get the answer wrong. What we're doing is we're combining like terms. Truly, in this example, the parentheses aren't even needed in either one of these sets here. We don't really need them. I'm going to just start rearranging some things. I'm going to locate the highest power, and that's this negative 2x to the 4th power. I'm going to write that first. Now, there are no other powers of 4. Now, I'm going to start looking for powers of 3. There's one. I'm going to see if there's any more. No more. Now, I'm going to see if there's any powers of 2. There's one. There's another. Now, I'm going to see if there's any just x variables. Here's one. And there's another. And lastly, do we have just any plain numbers? We've got one right there. And now you're just combining like terms. Negative 2x to the 4th, that is the only term of its kind. Plus x cubed, well, there's no other x cubes other than that one. These can be combined. 7x squareds plus 3x squareds mean we have 10x squareds. We can combine those. Negative 6x minus 9x is negative 15x, and then plus 3. That's your answer. Example B. The first parenthesis not needed. But the second one is, you're going to need to distribute that negative throughout the parentheses, and it's just going to change all the signs. And now we're going to combine like terms. I'm not going to rearrange this one. 8x to the 4th. Do we have any third powers? We do. What about second powers? No. What about just regular x's? There we go. Negative 5 or negative 5x minus 9x. Negative 14x, and then just our regular integers. 11 plus 3 is 14. That's your answer. Example C, we are just going to distribute. We're going to multiply this times this. That times that. And then this times that. You would then check to see if you can combine any like terms, but we cannot. Example, okay, that's foiling, that's foiling. Let's just do one of these. How about forget that one? Let's just do this one. Okay, let's foil. We're going to do this times that. this times that. And now this, that times that. Combine like terms if you can. We can combine these terms and notice they cancel one another out. There's your final answer. Okay, example F. Now listen, if you can do example F the way that I'm about to show you, you can do example G and example H. So pay attention. These are a little different. What you're doing with example F is you have to multiply that times that times that, and then x times -5. I'm going to do that part first. So x times x squared is x cubed. X times 3x. I'm sorry. I just missed something. My bad. X times 6x squared is 6x cubed. Okay. X times 3x is plus 3x squared. And then x times -5 is -5x. Okay, now we got to distribute this here, there, and there. All right, so let's do it. And whenever I start doing this process, look at where I write the result. -2 times 6x squared is -12x squared. -2 times 3x is -6x, and -2 times -5 is +10. Now combine like terms vertically for your final answer. That's it for that one. Okay, example G. Now we're not going to do all of example G, but I'm going to show you how you would want to tackle this one. I'm going to start by just pretending that first parenthesis doesn't even exist. I'm just going to FOIL these two. And then I'm going to combine like terms. I'm going to wrap that in parentheses, and now I'm going to include that. And then you know what you need to do from here? This times that, times that, times that, this times that, times that, times that, which I will let you do at your own time, and then you can check the answer key and see if you got it right. Example H. We have r minus 5 that's being cubed. What that means is we need to expand it. And then I'd cover that one up. Let's FOIL. Combine like terms. Wrap that in parentheses, and then let's bring back that other parenthesis that we covered up. And then you know what you do? That times that, times that, times that, and then this times this, times this, times this. Which, go for it, knock yourself out. And then check the answer key, see if you got it right. And then we have example I, which I'm not going to do because these make me want to pull my hair out, but I will at least give you an idea of what you would need to do. And if you're like, please, I really need to see this one done, talk to me in class and I'd gladly show you. So you would need to do this times that, times that, times that, and then this times that, times that, times that. And then lastly, you're multiplying a lot of things and then combining like terms. And should we see something like this on the review, I'll do it. But until then, no thank you. If you'd like to see it in class, though, tell me.